So my name is Rory Arnold. I am a finance and entrepreneurship major here at Baylor in my junior year. And I have a question 4 on the McGraw-Hill homework. And the McGraw-Hill homework says the continuous compounded annual rate return on a stock is normally distributed with a mean of 11% and a standard deviation of 15%. With 95.44% confidence, we should expect its actual return in any particular year to be between which pair of values? And so we are given multiple pair of values. And to solve this, it's pretty simple. All we have to do is understand that the mean is 11%, and we're going to use that in our equation because we're finding the lower and the upper bound. But first, we need to find the standard deviation of sigma. And so that is 15%, which is given. And the lower bound is found by taking the mean, which is 11%, and subtracting it by 2. So 2 times 0.15, because that is the standard deviation. And then we get 0.11 minus 0.3, which equals negative 0.19, or negative 19%. And then all we have to do is find the upper bound, and the upper bound is the mean, 11%, plus 2 times the standard deviation, 15%, and that equals 0.11 times 0.3, and that is 41%. And so we choose the answer negative 19 and 41%, and that is the correct answer.
My name is Adam Albar. I am a finance major, and I'm a junior, and I had question 5 from the McGraw-Hill homework. So the question states, using historical risk premiums from table 5.5, which I'm not going to show because it's super long, over the 1927 to 2021 period as your guide, what would be your estimate of expected annual HPR and the big/value portfolio if the current risk-free interest rate is 1.75%? So in order to solve this question, we need to calculate the expected annual HPR, so basically the holding period rate, using the given risk-free rate, which is 1.75%, in the data from table 5.5. So the mean excess return for the big value portfolio from table 5 is 12.02%, and the risk-free rate, which is given to us, is 1.75%. So the formula we would use to solve this equation would be the expected annual HPR equals the mean excess return plus 1. So the calculation after plugging it in would be the expected annual HPR equals 12.02% plus 1.75%, which would give you expected annual HPR of 13.77%.
All right, my name is Connor Rich. I'm a finance and entrepreneurship major, and I'm going to be going over question 14 from the first homework. So we have a 3-month treasury bill. The price is $9,925. The face value is $10,000. The maturity in months is 4, and then for other info, there's 12 months in a year, and the current inflation rate is 4.1%. So to be able to find the nominal and real interest rate for APR and EAR, we need to first find the just overall nominal rate, which is going to be, you're going to take the face value minus the price over the price. So in this case, it's going to be 10,000 minus 9,925 over 9,925. And what you're going to get for this is 0.007557, which is a small number. It's just 0.75% basically. And you're going to use this number and apply it to be able to find the nominal rates for each. So first for APR, you're going to do the nominal rate times 12 over the maturity in months. So this is going to be 0.007557 multiplied by 12 over 4. And what we get for that is 0.02267, and that number is going to go over here. All right, now to find the EAR for the nominal interest rate, we have to do 1 plus the nominal rate up here over 12 over the maturity rate, and that's going to be an exponent and then subtract by 1. So what that's going to look like here is 1 plus 0.007557 to the power of 12 over 4 minus 1. And that is going to get us That's gonna get us 0.02284, and that number is gonna go down here. Alright, so now we found our nominal rates for both EAR and APR, so now we need to find the real rates. And you can use the real return formula, and that's gonna be able to be applied to both. You don't have to use a different one like we did here. So for the real return rate, we're gonna do 1, and this is in parentheses, 1 plus the nominal return of these numbers that we found, not the one up here, over 1 plus inflation, and that's all gonna be subtracted by 1. So for the APR, we're gonna do 1 plus 0.02267, in parentheses, over 1 plus your inflation, which is 4.1%, or 041. And then subtract 1 for that. That's going to be negative 0.0176%. So your rate for APR is negative 0.0176. And then in this situation for EAR, we're going to do the same thing. It's going to be 1 plus 0.0028, or plus 0.02284 over 1 plus 0.041, all subtracted by 1 again. That is also going to be very similar to this. It's going to be negative 0.0174. So 0.0174. These are going to be your rates for your 3 months treasury bill.